Hello, welcome to the video on ratios. Just a couple definitions to do before we get started. First one, a two-term ratio compares two quantities measured in the same units. So that's what we want to write in the first blank. When we're looking at ratios, we're looking at those that are the same, right? So for example, we could be looking at two pieces of fruit, right? So those are the same, right? So the thing that we're looking at is fruit. Maybe we have two apples and seven pears, right? So ratio notation is when you have those two dots that look like that. So we'd say there's a 2:7 ratio of apples to pears. Now, three-term ratio is very similar, right? Again, we're still talking about the same units, so we're still talking about fruit, but this time maybe we add in bananas, right? So we could have two apples, seven pears, and maybe 11 bananas, right? So that's a three-term versus a two-term. You could have an infinite number term, so it can be four-term, a five-term, you could just keep on going. And there's a couple of ways, not just ratio notation to show ratios, but we can also show ratios in a fraction, percent, and in words. So let's do this example together. It says, try this. There are 14 hockey players, 9 soccer players, 23 adults in total. So if we were to do ratio notation, we could say that there's 14 to 9, right, hockey players to soccer players. As a fraction, we can't write 14 over 9 because the bottom always needs to be the total number. But we could write there's 14 hockey players out of a total of 23 athletes. Right? Or we wanted to represent the soccer players, we could say 9 soccer players over 23 as well. As a percent, again, we'd have to choose to represent hockey players or soccer players. But to do that, right, you start with your fraction. If we do hockey, we'll go 14 divided by 23, get a number, multiply by 100 like we did last unit. So that ends up being 0.61 times 100, or 61%, right, of the hockey player, or 61% of the athletes are hockey players. That's technically a ratio too. And then the last one in words, we'd write it out. We would say there are 14 hockey players for every 9 soccer players. Now, some of these ways, ratio notation, fraction, percent, and in words, can only be used at certain times. Right now, we'll kind of go over some of the situations that will probably be more obvious than you think. So try this example here on your own first. Write each ratio notation, or ratio and ratio notation, a fraction, a percent in words. So I'm only giving you one. So we only need to do the one. Because in our class, 7 out of 30 students live on Bowen. What is that as notation, fraction, percent in words? So pause the video and then come back in a second. Great. Okay, welcome back. So we're going to use the above example to show part ratios versus part to whole. Part to part would be, in this example, if 7 students were Bowen, right, then the other part would be the remaining students who live somewhere else. 23 students somewhere else. So we would express this as a ratio. We could say that it's 7 to 23 to other. Right? Now, the question before didn't really specify that it should be part to part or part to whole. So there's a good chance you probably did a part to whole, which would be 7, right, out of 30 total, which would be Bowen, right, total students. And part to part to whole. So read the question carefully to see which one they require. If we go back to our part to part, it says, what form could you use to represent this part to part? Well, we did it in fraction notation. We can't really put 7 over 23 as a fraction or a percent, because like we mentioned before, you need to have the total to do that, right? We could find the total easily, but not representing the part to part. We can do it in words. For part to whole, we can do all of them because the total is obvious. It's a small little thing, but it is significant. All right. So when you turn the page over, we have a couple of word problems to do. So the first one says, we've got some pictures of oranges and apples here. Apologize about all the fruit analogies. But Owen wants to write the ratio of oranges to apples. How does he know whether to write 3 to 5 or 5 to 3? Because we've got 3 oranges, 5 apples. Now the answer to this question is whatever word comes in the problem first is the number that comes first. So they say oranges first, so we should put the number that represents oranges first. Then they say apples, then goes apples. If you flipped it around, it would be incorrect. All right, so read carefully. Now the next question says, your friend missed the class where ratios were introduced. Use an example and draw a diagram displaying the difference of a part to part and a part to whole. So why don't you talk about the fruit and the apples and the oranges to that one. 2 examples of how ratios are used in daily life, right? And then we'll share some ideas together next day. And 4, the fraction 2 over 5 can be interpreted as 2 parts out of a total of 5 parts, right? A part to whole. Use a diagram to show this. Okay, so pause the video, finish off questions 2, 3, and 4 on your own. All right, last question. We'll get it going together here. So the Ashley has a recipe for fruit punch that calls for 3 cans of frozen orange juice concentrate, 2 cans of raspberry juice concentrate, 1 can of lime juice concentrate. For each can of juice concentrate, the directions say to add 3 cans of water. All cans are the same size. Ashley makes 1 recipe of the fruit punch. So this table is going to just help us organize here first. So the juice, right? If we go back to the question, we've got 3 orange, 2 raspberry, 1 lime, right? So that's a total of 6 cans of juice. And then for every can, we put 3 waters. So we have 3 oranges. That's going to be 3 times 3, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 9 waters here, 6 waters here, 3 waters here. So that's a total of 18 cans of water. Right, so total punch cans when we're all done, right, would be 24. Right, so we have a neat space that can hold 24 cans. So, question says, what's the ratio of orange juice to lime juice? Orange to lime, right? They say orange first would be 3 to 1. That's in ratio notation, and let's express it in 2 different ways, right? So I could do it as a picture, right? That would be one way, or I could do it in words. There are 3 cans of orange for every 1 can of lime. Okay, so your job is to do 2, 3, 4, and 5. Right, please come with a sheet complete for next day. And if you have any questions, you can ask in class. Thank you.